So in this lesson, we're going to work a little bit more with the unit circle. We're also going to talk about finding trig functions of angles and other quadrants, thinking from the unit circle, but also learning how to do that without actually looking at the unit circle. So this question says a point on the terminal side of theta intersects the unit circle at this point. What is the sine of theta and what is the cosine of theta? So we're going to use this point, but then it says we are going to draw a picture to support our answer. So if this is on the unit circle and only on the unit circle, the sine of theta is equal to the y value, which is 4/5, and the cosine of theta is equal to the x value of that point, which is 3/5. So I can see this angle is in the first quadrant because we have a positive point. So to support my answer, here's my circle. Here's my angle. 1 for the unit circle. The x is 3/5. The y is 4/5. There's my theta. And we can see that sine is opposite over hypotenuse, 4/5 over 1. And cosine is adjacent over hypotenuse, 3/5 over 1. So that is correct for my picture. Now, the biggest mistake people can make, they'll see something and they'll say, here's a point, 4, 7. And they'll say the cosine of the angle is 4 and the sine of the angle is 7. So first off, and you'll see even more when we do graphs, you cannot get a sine value of 7 or a cosine value of 4. If this point is not on the unit circle, which we can definitely see, just like we did 2 lessons ago, you have to draw a triangle and find the hypotenuse. The hypotenuse for that point is not 1 with the angle, so we can only do that if we see these directions where we actually take the values and just go directly to the sine and cosine values. So my next one says, now I have a point at -2/5, radical 21 over 5, so we are headed into the second quadrant. Probably not perfect proportions here, but we get the idea. So it's -2/5, radical 21 over 5. So I drew my picture first, but I am going to go back and just find what I need. So the sine of theta is the y value. So that's radical 21 over 5. The tangent of theta is y over x, right, for the point on the unit circle. So that's radical 21 over 5 over -2/5, which equals radical 21 over 5 times -5 over 2. So we have negative radical 21 over 2 for our answer. Now, checking my quadrant is always a good idea. I'm in the second quadrant. With my ASTC, I expect sine to be positive, which it is. And I expect tangent to be negative in the second quadrant, which it is. So that's always a good double check. Even if you think you are thinking about the appropriate signs, it's easy to miss them. Looking back to my picture, I know it's a little messy now, so I'm going to retrace it in blue. If I'm doing sine for this angle here, it would be radical 21 over 5 over 1. So this one checks. Tangent, I'm not going to go through the whole thing, but that would be opposite over adjacent, radical 21 over 5 over -2/5, which was that original fraction that I started with. This one, we have the terminal side of theta. I'm not going to draw this one first. Passes through this point on the unit circle. What is the tangent of theta? That is y over x. And I can start to see things. The last one I wrote everything out, but I can see, and this is usually true, that we have that same denominator for both fractions. So I can just do y over x. I know the 41s are going to cancel, so y over x is going to be -40 over 9. For the cosecant of theta, Sine of theta is y, so cosecant of theta is 1 over y. So that's going to be 1 over negative 40 over 41. Keep change flip. We are going to have negative 41 over 40. Checking this point, we have positive, negative. So I am in the fourth quadrant. I think that's a winner for the worst circle. And we see that we should have tangents negative, which it is. Cosecant is negative, which it is. Being careful, I'm going to erase those actually. Not to make it, when I'm writing these values, I don't really want to write it on the word. I'm just writing down what I'm checking. So even on that one above, which for some reason I can't erase that negative sign above the red tangent theta, but I'm not writing it on it. It's just more of a check. So from here, if I label my picture, and this is the last one I'm going to label, from this point, x is 9 over 41, y is negative 40 over 41, and that's the hypotenuse. So if I do, for this one, here's my angle I'm working with, I can do opposite over adjacent, and we see those 41s would cancel. I would get negative 40 over 9. Cosecant of theta would be 1 over, or hypotenuse over opposite, which is the fraction that I see here. This last one, I'm not going to use the unit circle. I'm not going to draw a picture. The idea is you are headed towards this idea that we don't really need the triangles anymore to do trig. Most of the things on your test, you're still going to draw them, and even on these, it's a good idea to check, but ultimately, we can just have the circle. So secant of theta is equal to 1 over x, the reciprocal of cosine. So that's 1 over 5/13, which equals 13/5. I am once again in quadrant 4, positive, negative, so it makes sense that cosine value, secant goes with cosine, that would be positive. So on this page, we're actually going to do the setup for these problems, and then we'll do one of them, but then I'll probably do more examples on the next page. So for this, we're going to start out and we're going to copy down that special angle table that everyone should have memorized now. So there's my degrees, there's my corresponding radian values, and then my sine values go 1, 2, 3, put my radicals on, all over 2. Cosines do the opposite for those angles. And tangents, you can either do sine divided by cosine, or hopefully by now you just kind of have it memorized. So it's radical 3 over 3, 1, and radical 3. So now we're going to actually use that table as a reference, and we're going to use that table to find the values of sine, cosine, or tangent of angles in other quadrants. So the first thing we want to do with this process, and I'm going to just draw this one, we should recognize that 225 is in the third quadrant. So we're going to determine the quadrant and the corresponding sign of the trigonometric value. So if I'm in quadrant 3, sine is negative. So I'm just going to write a negative sign next to it. The next thing we're going to do is find the reference angle. So we're going to find what angle goes in here, because we know the actual angle goes all the way around, but we want to find that angle with the x-axis. So that's going to be 225 minus 180. How far away are they? We want a positive angle, so I'm going to put the bigger number first, so that's 45. So that means the sine of 225 is equal to the negative sine of 45, because we can see it's in the same placement. If we think about the unit circle, it's on like the same color line, except we need to get a negative answer. So now I can just use my table. We found the reference angle. We're finding the trigonometric value for the reference angle with the sign we chose. We chose negative because its sign is, or the other sign, the trig function is in the third quadrant. Sine of 45 we know is radical 2 over 2, and we're going to be super careful to remember to put the negative sign on it. So if you think about the point on the unit circle at 225, it is negative radical 2 over 2, negative radical 2 over 2. That second, the y value is the sine value, but we want to get to the point where we're thinking about the unit circle, but it's not like we need to stare at a filled in unit circle to answer these.